Mastering gross error detection. Leadership must hone gross error detection, or risk catastrophic failure. Who is responsible for prioritizing and resourcing gross error detection efforts, and what are the key performance indicators, KPIs, used to measure the effectiveness of these efforts in achieving operational excellence? In the pursuit of operational excellence, gross error detection is a crucial aspect that requires meticulous attention. It is essential to identify and correct gross errors to prevent catastrophic consequences, ensure compliance with regulatory requirements, and maintain a reputation for reliability. To achieve this, it is critical to establish clear responsibilities and measurable performance indicators. The responsibility for prioritizing and resourcing gross error detection efforts lies with the organization's leadership, specifically the operations manager or the process safety manager. They are accountable for allocating necessary resources, including personnel, equipment, and budget, to identify and rectify potential gross errors. This includes providing training and guidance to the team, ensuring that they possess the necessary skills and expertise to detect and correct errors. To measure the effectiveness of gross error detection efforts, several key performance indicators, KPIs, should be established and tracked. These KPIs should be quantifiable, relevant, and actionable, providing insights into the efficiency and efficacy of the gross error detection program. 1. Gross error detection rate, GEDR, the number of gross errors detected per unit of production or operation. A higher GEDR indicates a more effective gross error detection program. Formula: GEDR equals number of gross errors detected divided by total units produced or operated, times 100. 2. Mean time between errors, MTBE, the average time between the occurrence of two consecutive gross errors. A higher MTBE indicates a longer period between errors, suggesting a more effective detection program. Formula: MTBE equals total operating time, total downtime due to errors, divided by number of gross errors. 3. Error detection efficiency, EDE, the percentage of gross errors detected before they result in significant consequences. A higher EDE indicates a more efficient detection program. Formula: EDE equals number of gross errors detected before consequences divided by total gross errors, times 100. 4. Root cause analysis, RCA, completion rate, the percentage of gross errors with completed root cause analysis. A higher completion rate indicates a more thorough understanding of error causes and a stronger foundation for corrective actions. Formula: RCA completion rate equals number of RCAs completed divided by total gross errors, times 100. 5. Corrective action effectiveness, CAE, the percentage of corrective actions that successfully prevent error recurrence. A higher CAE indicates more effective corrective actions. Formula: CAE equals number of successful corrective actions divided by total corrective actions, times 100. 6. Error recurrence rate, ERR, the percentage of errors that recur after corrective actions. A lower ERR indicates more effective corrective actions. Formula: ERR equals number of error recurrences divided by total gross errors, times 100. 7. Training and competency, T&C, the percentage of personnel trained and competent in gross error detection and correction. A higher T&C indicates a more skilled workforce. Formula: T&C equals number of trained personnel divided by total personnel, times 100. 8. Audit and inspection frequency, AIF, the frequency of audits and inspections to detect and correct gross errors. A higher AIF indicates a more proactive approach to error detection. Formula: AIF equals number of audits and inspections divided by total operating time, times 100. By tracking these KPIs, organizations can evaluate the effectiveness of their gross error detection efforts, identify areas for improvement, and make data-driven decisions to optimize their operational excellence initiatives.